Okay, this is a continuation of my Calculus 1 logarithmic and inverse trig derivatives lab, and this is number 8. And I promised you that I would show you how to do this a different way using our natural log rules or our log rules. So the first thing you can do is, if you look at this and say, I realize this is really, okay, I can write it this way as the natural log of x plus 1 to the 5th over x plus 2 to the 20th raised to the 1/2. And if I do power to the power, this is really the natural log of x plus 1 to the 5/2 over x plus 2 to the 10th. Okay? So now, since I've kind of written it that way and simplified it a little bit, I can now look at it and say, wait a minute, look, in here, if I have the natural log of something divided, I can actually pull it apart. So notice I'm not doing the derivative yet. I'm just rewriting it. So I have the natural log of x plus 1 to the 5/2 minus natural log of x plus 2 to the 10th. And then I'm using the log rules to bring down my exponent. This is not the power rule. I'm just bringing my exponent down. So I'm rewriting this to say y equals 5/2 the natural log of x plus 1, okay, minus 10 natural log of x plus 2. So really all I did, starting from here to across, was first of all simplify this with our exponents and power to the power. Then I used log rules to separate it or expand it. Then I brought down the exponent. So now I've written it in a different way where I have y equals 5/2 natural log of x plus 1 minus 10 natural log of x plus 2. Now that it's this way, I can now start doing the derivative. And so the derivative is going to be y prime. So right here is where I start the derivative. Equals 5 over 2 times x plus 1, because it's 1 over u times u prime, and it's 1, so I have 5 over 2, minus 10, okay, over x plus 2, because it's 1 over u times the derivative. So that's really what it is. And so I'm going to write it a little bit nicer, so I have a 5 over 2 times x plus 1 minus 10 over x plus 2. That is the derivative. But what we're going to do is continue on and get it to be a single fraction by actually finding a common denominator. So let's continue on. So I have y prime has a common denominator of 2 times x plus 1 times x plus 2. So the first term, I've already have the 2 and x, so I'm going to multiply by x plus 2. The second term, I have x plus 2, so I've got 10 times 2 times x plus 1. So I have 5x plus 10 minus 20 times x plus 1. All over 2 times x plus 1 times x plus 2. And if I continue on, I have y prime is 5x plus 10, and now I'm going to do the distributive property, minus 20x minus 20 all over 2 times x plus 1 times x plus 2. So I end up getting minus 15 minus 10, minus 15x, sorry, minus 15x minus 20 all over 2 times x plus 1 times x plus 2. And the only difference was this, which is perfectly fine, is in the answer key, they actually factored out -5. So it's x plus 4 here. It didn't do anything to simplify this anymore, but they just pulled out that in the numerator, and that is the derivative. So this one is fine as well, because this one I would accept as well, but this one is what the answer key was, where they factored out -5. So this is number 8.